Okay, so today we're going to continue on with practicing of graphing of these polynomial functions. So I know when you do the homework tonight, I know at least one of them is just a quadratic function. So you're just going to go back to when we were graphing quadratics, finding the vertex, axis of symmetry, all of that. So that's all that one is. But in this section, it's supposed to be polynomials of higher degree. So it should be exponents that are bigger than an x squared, but in the homework we did give you an x squared, just to review that. So again, this is the same slide from yesterday. It's strategies for graphing. You should first determine the end behavior, then find the zeros, find the multiplicity for each of your zeros, find the y-intercept, and then also plot additional points. Now, generally what we do for the additional points is if you have a graphing calculator, especially the TI, it'll actually give you a table of all the ordered pairs on your graph. And that's how a lot of times we were getting the additional points, is right from our calculator. Now, we can see the additional points also if you're using Desmos. So let's go ahead and let's practice the graphing. Now, if this were a question on your test, this would be a reasonable question where we could use the possible zero list. Because notice my last term is positive 2. So if I do the list of possible zeros, remember you take the last term, which is positive 2. So factors of positive 2 are plus and minus 1, plus and minus 2, divided by plus and minus 1. So your list of possible zeros are just going to be negative 1, positive 1, negative 2, positive 2. So if you were not keying this into Desmos and I said, find the zeros, find the multiplicity, graph it, we could do it without a graphing calculator here, just by guessing and testing. So let's go ahead and first look at our end behavior. It's an odd exponent, so I know the ends of my graph are going to go in opposite directions. And it's a negative in front of the x cubed, so it's actually going to rise to the left, and it's going to fall to the right. So this is my end behavior of my graph. I can also, right away from my equation here, I can find my y-intercept by plugging in x equals 0. So my y-intercept is this constant right here. It's the ordered pair 0, 2. And now, if I were not keying this into Desmos, I would start by doing a bunch of synthetic division problems using these 4 numbers. Now, if you have opened up the notes that I just added, the part 2, I'm going to do synthetic division, and the 0 I'm using from my possible list is the negative 2. Now, if I would have chosen any of these other ones, I would just turn them into my remainder theorem, and I would use them as additional points. I'm actually going to go ahead and do synthetic division using the negative 1 and the positive 1, because I'm going to need additional points at those x values. But let me go ahead and do the 0. I'm going to go ahead and put in my coefficients. I'm going to put in the negative 1, the positive 2, the 9, and the positive 2. I'm going to bring down my negative 1. I'm going to multiply it. I'm going to add the column. I'm going to multiply. I'm going to add the column. And I'm going to multiply one more time. Now, because I went and I looked at the Desmos graph, I knew that this negative 2 was already my answer. I just need to get the quadratic equation from this. So now I'm going to add in remainder, constant, x squared. So negative x squared plus 4x plus 1 equals 0. I now have a quadratic equation that I could either try to factor, which I can't because there aren't any factors of 1 that will give me 4. And then from there, I'm going to do quadratic formula. Now, because I had already looked at Desmos, I already knew I couldn't factor it because my answers have radicals. Now, if this would have been able to be factored, I would have preferred to not have a negative x squared term. So I would have factored out a GCF of -1 and gotten this function to try to factor. But again, it's still not factorable. So my A term now is this 1. My B term is the -4. My C is the -1. I'm doing quadratic formula. So opposite of B, plus or minus B squared minus 4 times A times C. All divided by 2 times A. Going to simplify what's under the square root. So 4 plus or minus 16 plus 4. Going to add what's under the square root. I get the square root of 20. I now have to break down the square root of 20. It will simplify into 4 times 5, and then when I break it down, it becomes 2 square root 5. I now need to simplify. I can divide all these by 2. So my simplified answer is 2 plus or minus the square root of 5. So now my 3 zeros written in simplest radical form are going to be the one that I got from the division. So I have one at x equals -2. I've got 2 minus root 5 and 2 plus square root 5. Now, just to show you how it equates to the decimals we saw from Desmos, the square root of 5 is approximately equal to 2.36. I'm rounding it, 2.236. So what I'm going to do here is I'm going to put that in here, and I'm going to do 2 minus 2.236, which gives me -0.236. And then here, 2 plus 2.236, and I get 4.236. So as far as the numbers on the graph, this is what we saw. But when I ask you to list the zeros, I want it in simplest radical form. And the way that you're going to get those radicals is by doing synthetic division with one of your rational zeros, and then you'll get a quadratic equation that you can either use quadratic formula. So I'm graphing all of these intercepts, which are also zeros, and then 1, 2, 3, 4.2, and then the y-intercept. And now I'm going to also add in my end behavior. I know that this far left zero, from here, this point on, it's going up, and this one's going down. Now I have to see how it's going to wiggle in the middle. And I need to figure out where it's going. Now, also I need to discuss multiplicity, because this is going to decide, does my graph go through the x-axis or does it bounce? So because each one of these zeros only happens one time, I only see one of them, this tells me that each one of these zeros has a multiplicity that's odd, which means that it's going to cross the x-axis at each of these numbers. It's not going to touch and turn. That's where the multiplicity is going to help us. So now, let me find a point in between. So remember how I told you back here with my list of possible zeros? If I would have done it by guessing and testing, by plugging in and doing synthetic division with -1 and +1, those are actually going to be my additional points because I need another x value in between here, and that x value that I'm going to be plugging in is -1. So I'm going to be doing synthetic division with -1. Now, if you prefer to just take -1 and plug it in for the x's into your original equation, you can also get order pairs that way. But I think the synthetic is a lot easier. So let's go ahead and do the synthetic to get another order pair. Bring it down, multiply, add the column, multiply, add the column, multiply, add the column. So my additional order pair, I take this and put it with the remainder, and it becomes a coordinate. And now I can come over here and graph -1, -4. Let me come over here. And this tells me that my graph is going to come down here. And now then it's going to go back up to the other 0. And because it has a multiplicity of 1, it cuts through. And now I need to see from this y-intercept, does it keep going up or does it go down again? So I'm going to now plug in another x value that's in between here. And again, I'm going to use +1. You could plug in 2, you could plug in 3, you can plug in 4, as long as it's a number in between these two zeros. So I'm going to plug in 1. So synthetic again, using +1, -1, 2, 9, and 2. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. Order pair is 1, 12. So now I know up here, my graph is going to go from on x equals 1 up to 12. So I'm going to put it way up here somewhere. Again, it's an approximation. I just want to see how the graph is waving through here. So it's going to go from here on up and then back down to the other 0. Now, one other thing, and I don't know if I told this class or not, but to figure out how many turning points there are, you would take your biggest exponent here, the x to the third, always subtract 1 from that biggest exponent, and this tells me I'm going to have 2 turning points. So what I mean by that is, notice here, it's coming in here. Oops, let me do a different color. It comes in here, it turns around, it's going down, and it goes back up. Hits here, turns around, goes back down. So you can just take the biggest exponent, subtract 1 from it, and that'll be how many times your graph turns, from being increasing to decreasing or decreasing to increasing. So again, if you take...
How did you say you got the turning point again?
You take the biggest exponent. So if your polynomial is already written from biggest exponent down, you take that leading term, you take its exponent and subtract 1 from it.
Oh, okay.
And that'll be how many times your graph turns. So if you look, the next slide is actually the graph from Desmos. So if I zoom in here, we can see that our zeros are going to occur at -2, 0, 4.236, and -0.236. Now, key thing here, and this is important, when we take the test, I don't want to see you list your irrational zeros as decimals. So the only rational 0 I have here is -2. These 2 zeros right here are radicals. I want to see your zeros listed in simplest radical form. So for anybody who's going to end up listing this as a 0, I'm going to know you used a graphing utility. And if we decide not to use a graphing utility, that's not going to be a good sign for me. Okay, so all zeros are going to be written in simplest radical form. The way that we're going to figure out what radicals these numbers represent is I'm going to do synthetic division using my one and only rational zero here, which is -2, and then I'm going to break it down so it's quadratic. And then I'll be able to use quadratic formula to get my zero in simplest radical form. So now let me go back to where the problem is. Included, here again is the graph. Their scale is a little bit different. Now notice this highest point up here, they actually plugged in 2. I plugged in 1 and I got 12. So really I had stopped my graph here, but it's okay. It's still supposed to go, but all I was looking for was that you knew it was rising and then coming back down. I don't care that you didn't hit the highest point. Now, if we were requiring graphing calculators, your graphing calculator actually gives you a table of all of the ordered pairs that are on your graph, and you would have just looked for the highest y value from it. So again, I just want to see the general direction of where your graph is waving along. Pretty good? Okay, let's try the next one. Desmos graph that so for number 7, this one's a little different setup. However, it's a lot easier than what we've been doing because it's already factored for me. So all I need to do is take each of these binomials and set them equal to 0. So this will be my first one. I set x minus 3 equal to 0. I'm going to add 3. X equals 3. Now, notice it's supposed to be raised to the second power. All this tells me is that my 0, x equals 3, occurs 2 times. Then I'm going to do the next one, the x plus 1. And if you notice, I've got it again and again. So x plus 1, that factor occurs 3 times. So I just need to subtract. And I have x equals 1, but it occurs 3 times. I have 1 from here and 2 from here. Now, notice I've got 5 zeros. This is going to help me determine my end behavior. So again, normally you would look at the first term's exponent, but it's not factored out and multiplied out. It's in factored form. So I have 2 zeros from this one, 1 from here, and 2 from here, for a total of 5. So my end behavior is based on x to the 5th. And then it had a negative sign in front. So remember, the normal odd behavior would be falling left and rising right, but it's going to rise left and fall right, because it's an odd exponent and it's a negative sign in front. So I'm rising to the left but falling to the right. That's my end behavior. Now, unfortunately, it's not already multiplied out, so I need to plug in x equals 0 to get my y-intercept, which isn't that bad. So again, remember to find the y-intercept, you set x equal to 0. So I'm going to plug in zeros. So y equals negative sign, and then 0 minus 3 squared, 0 plus 1, 0 plus 1 squared. And then I'm going to solve this. Negative 3 squared, 1, 1 squared. Negative 3 squared is 9. 1 times 1 is 1. And then this just gives me my y-intercept is going to equal 0, comma, -9. So I actually have to plug in the 0 and solve it to get the y-intercept. Now let's go back to my zeros and determine the multiplicity. So for this 0 here, you see how you have 2 of them? 2's an even number, so this has even multiplicity. When you have even multiplicity, it's like a bounce. Or what you're saying is it's going to come up, it's going to touch the x-axis, and then it's going to turn away. That's where the multiplicity is going to help us. The -1, 0, this one occurs 3 times. 3 is an odd number, so this has an odd multiplicity. And this one, when it's odd, means it crosses the x-axis at that number. So let's go ahead and add this information onto the graph and then also see which additional points we need to find. So I'm going to graph a 0 at +3, -1, and -9. Well, my -9 is somewhere down here. Let me just put it right here. We're going to say that this is the ordered pair 0, -9. Let's add in the end behavior to these 2 zeros. So we know it's going up here and down here. And now we just have to figure out the movement in between. Now remember, at this +3, 0, remember this is going to be a touch and turn. So it's not going to go through the x-axis. So let's go ahead and figure out what we need here. So I'm going to go ahead and look for, so since this is going to cross through the x-axis, it's going to come down here to this one. Now I have to decide, does this touch this y or does it keep going down? And it does keep going down. So let me do a synthetic. Actually, I can't do synthetic because it's factored. I'm going to find another x value order pair. I'm going to find another order pair in this section. And I'm going to plug in x equals 2 into my original equation. When it's already factored for you, you're not doing synthetic. You're actually just plugging in the numbers. So to get another order pair, which is going to be 2 comma something, I'm going to plug in a 2. So negative sign, 2 minus 3 squared, 2 plus 1, 2 plus 1, but it's squared. Negative sign, -1 squared, 3, 3 squared. 1 times 3 times 9, and I end up with -27. So I'm going to be graphing the order pair 2, comma, -27. So I'll come over here, and it's going to come way into my work. So my order pair should be down here somewhere. So what it's going to do, it's going to come down here, and then it's going to go back up to +3. But remember, it's a touch and turn. So it touches it, and then it goes to the end behavior. And that's your graph. Now, you can always plug in as many x values as you want if you want a more precise graph. Everybody with me so far? Okay, Okay, so again, we set each of the factors equal to 0 because we're trying to find out where it's touching the x-axis. And then I also found my end behavior. There were 4 zeros. So it's based on an x to the 4th, a negative x to the 4th, and behavior, both left and right side pointing down, or both sides falling. And then I plugged in 0 to get my y-intercept. So let me graph these 3 points and also add in the end behavior. So I'm going to graph -2, +3, and my y-intercept, which, whoa, it's way down here. And let's just say it's way down here at, and we'll call this 0, -36. So again, my end behavior on each of these zeros, it's pointing down. And now remember, these are touch and turns. So really, this is coming back down again, but we got to figure out where it's coming down to. So again, we can plug in additional points to get to see where it's hitting. So like this one, I could probably bring it down so it touches here, but let me plug in, say, +2 to see where another point is over here. So I got to actually plug it in because it's factored. So I'm going to come up here, negative, and then I'm going to do 2 + 2 squared, 2 - 3 squared. So 4 squared, -1 squared, -16 times 1, and I get -16. So I'm going to be graphing 2, 16, or -16. So then it's going to come, oops. So I'm going to come over here at 2 and 16, and I can say maybe it's around, let's say 216 might be here. So then it's going to come here, and it's going to go back up. So again, this can keep going down. Again, if you look at the Desmos, it's right here. And it sort of looks like that M that I just made. So again, we have our 2 x-intercepts. And notice they don't cross because it had a multiplicity that was even, touch and turn. And then I have my y-intercept down here.
On the homework, I was looking at the homework for 3.2, and there was a question with like fractions.
On to the next one. It's got the Desmos graph. Notice it's only touching the x-axis one time. This should be a clue that your other 2 zeros are imaginary. Okay? So if you were to just list your 0 as -1, you're going to get it wrong because you do need to list the imaginaries. The imaginaries are not x-axis or x-intercepts, but they are still zeros. So what I'm going to take away from this Desmos graph is that I need to do synthetic division with -1. And here was the graph. All right, so for the next one, again, it's still asking us using what we've learned. So on this one, if I were to do guess and test, or list the possible zeros, it's just the factors of +and -1, +and -7 over +and -1. So the only ones that I'd have to try are going to be these 4. Now, if you look at the next slide, let me go back here, and I'm going to set up my synthetic, and I'm going to do -1, 1, 6, 12, and 7. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. I already knew I was going to get a remainder of 0 because I looked at the Desmos graph. If you did not look at the Desmos graph or your graphing calculator, then you would have started slowly going through this list of 4 numbers until you found the one that worked and gave you a remainder of 0. Now I have a quadratic equation that I can use quadratic formula to get the imaginary zeros. So I have x squared plus 5x plus 7 equals 0. My a is 1, my b is 5, my c is 7. So what I'm going to do here is opposite of b plus or minus b squared minus 4 times a times c, all divided by 2 times a. I'm going to simplify this. I get 25 minus 28 over 2 times 1, which is 2. Negative 5 plus or minus negative 3 under the square root. And now I need to simplify the negative 3, and it becomes negative 5 plus or minus I square root 3 over 2. So your 3 zeros are at negative 1, negative 5 minus I root 3 over 2, and negative 5 plus I root 3 over 2. Just looking at the graph, you're going to think the only 0 you have is negative 1, but you do have 2 imaginary zeros. You only have one x-intercept, and that's negative 1. Now let me go back up. Let's get the y-intercept and the end behavior. So if I come back up here, this one is not in factored form. It's in standard form. So this is my y-intercept, 0, 7. My end behavior is based on an x cubed. So we know it's going to fall to the left, rise to the right. So I'm going to graph my one and only x-intercept, my y-intercept, and add in the end behavior. So my y-intercept is at 0, 7, which is right here. And then my x-intercept is at that negative 1. Let me add the end behavior to my one and only x-intercept. So it's going to go down here, and then it's going to go up from here. And it's supposed to touch there. And that's your graph. Here, because there were no other zeros to find additional points in between, you can just get away with connecting the x and the y-intercept. And again, it's taking on the shape of the x cubed graph, so it should be look like that. So it should probably have a little bit more wiggle to it. Let me see. So it should probably be more like here. It's got to stay on this side of it. So here, there, like that. Again, you can see it on the Desmos graph. Now, numbers, the rest of the examples, I'll just tell you, use a graphing utility. Now, again, we could do this by hand or use the graphing utility. Realize that we've got 2 zeros coming out of this one, and they're both going to be imaginary. So if I solve this, I get this, square root it, x equals plus and minus I root 3. And then this one's going to give me 2 solutions. They're both going to be x equals 1. And this is going to give me x equals negative 4. So I get 2 zeros out of this one, 2 out of here, 1 out of here. So it's going to be based on an x to the 5th. And there's no negative sign. So we know it's going to be falling and rising to the right. And again, I will not see these 2 imaginaries on my graph. I'm only going to see these 3. This will be a touch and turn. This is going to cross. So here to the utility, the Desmos, here's the graph. Remember, this is the touch and turn. This is the 0 that only occurred once, and that's why it crosses the x-axis. And then they also figured out the y-intercept. And then in the notes, it also has, you can see them all. They're here. Again, you can use it to confirm. However, the other equations, I keyed them into Desmos. Also solve all of these by practicing and doing them by hand, and then checking them with your graphing utility. So that is it for 3.2. So when you're doing the homework tonight for this 3.2, you're still doing everything by hand, but again, use your graphing calculator or your graphing utility to check your graphs. So that is it for 3.2.